Bismillahirrahmanirrahim. Assalamu alaikum. This is EE340 and Umar Johar is with you. I will be doing the experiment for EE340 first experiment, which is titled electric field and potential inside the parallel plate capacitor. We will do the experiment for you. You have been introduced on the experiment by your instructor. This experiment will be done for you, so you can collect the data to be able to prepare the report. So we will be filling the different tables that we have here, so you can follow us. Okay, we will do each part and then we will tell you what will be the reading for each of the parts using the different meters that we have. I will introduce you on the setup first, and then I will conduct the experiment. So it will be a demonstration for you, but you are expected to collect the data from the video and then prepare your lab report and submit it next week, of course, when you come to experiment number 2. What are we trying to do today? Of course, you know what's the parallel plate capacitor. These are our two parallel plates. This is just a simple sheet, of course, and we are trying to create a parallel plate, and so we have two sheets there. We know that if you have a parallel plate and you put a voltage inside, there will be an electric field inside it. We know that this electric field will be related to the material that is inside, the size or the distance between the two plates that you have, and the voltage, of course, that will be applied across it. We know this relation and we are trying to verify it. So what we will do is we will apply a voltage and measure the electric field that will be between the two plates, and then we will vary the voltage again and then measure the electric field in steps. In the second part, we will be varying the distance between the two plates, and for each distance we would like to see also what will be the effect on the electric field in this case. And then we will try to change the material inside. So we will be having different materials, but we will most probably do one of them, so we can have different materials inserted inside the parallel plate capacitor, and see what will be the effect also of the presence of a material other than the free space or air. Now, to be able to do this, first we have to construct our parallel plate capacitor. So we need to have two plates. They have to be parallel, meaning that the distances in all the sides of your parallel plate have to be the same. So if you are putting it like this, it is not a parallel plate because the distance here is different than this one. So you have to make sure that they are parallel. And to do that, we will be measuring the distance between the two plates from this side and from this side also. Or you can measure from this side and from this side, it will give you the same thing. And another thing is we need to make sure that we have large intersection between the two plates. So you cannot have them one like this, because now the parallel plate will be only for this portion, because this does not have anything in parallel to it and this does not have anything in parallel to it. So we have to make sure they are parallel, and they have to make sure also they are seeing each other. Okay, so now we are done with constructing our parallel plate capacitor. And then we will apply voltage across them. And to be able to apply voltage across them, we will be just connecting a voltage source. These are the two wires that are connected. This is connected to this plate through the rod that we have here. And this is also connected to it through the other rod. And this is connected into a voltage source, where I will be varying the voltage by using this. We have here a voltage source which has three terminals where we can vary this or this or this, or we can use three voltage sources at the same time if we want to. This is one of them, which is going to be connected directly into the power plate capacitor, and I will be varying the voltage that is across this. And we need to measure how much is the voltage, and to do that we will be using a voltmeter. This is a DC voltage, so we will be using a simple digital multimeter to measure the voltage in DC, of course, and it is connected parallel to it. So you can see this is parallel connection, two wires here, two wires there, and I will be changing the voltage by using this. And you can see as I change the voltage here, the voltage will be changing, of course, in there. Okay, so this is a parallel plate, and they are connected to a voltage source, and that voltage can be varied. This is what we achieved now. Now we want to measure the distance. We said we can measure it using a simple ruler, and we need to measure also the electric field inside. We know that the electric field inside the parallel plate capacitor is uniform. It's all the same. It is equal to each other, and depends on the distance and the voltage we said. So we will be using a special device that measures electric field, and we call it electric field meter, and this measures the electric field inside at the tip of our parallel plate, which is of course going to be uniform everywhere, and because of this it will give us the same value. Okay, this is a special device that measures the electric field, and you can notice that it does not have any display in it, but what it will do is it will measure the electric field, and then it will give you a voltage that represents that electric field. And we will be measuring just simple voltage here, and that voltage will represent the electric field. Of course, electric field is in volts per meter, and the conversion between the voltage that you will be measuring using this, okay, these are the two terminals that are measuring the voltage, will be equivalent to a given value of an electric field, and the conversion is given to in here. So every 1 kilovolt per meter, which is the electric field, will be equal to 10 kilovolts, and this is if you are using the first range. So we have similar ranges like this one also for it. Yeah, 10 volts. 1 kilovolt per meter is equal to 10 volts, and 10 kilovolt per meter equals to 100 volts, and so on. So if you measure 10 volts, it means you are measuring 1 kilovolt per meter, and this is if you are using the first range that we will be having here. And you can notice that we have different ranges here. So if I am using the first range, you can see the light, then this means that 1 kilovolt will be equal to 10 volts. If I use the second range, so I will change this now into the second range. This is similar to doing this, okay, but for the electric field, then 1 kilovolt per meter will be equal to, or let's say 10 volts will be equal to 10 kilovolts per meter. It is easier this way. And if I use the third one, then the 10 volts will be equal to 100 kilovolts per meter. Okay, so the conversion will be either 1 equals to 10, or 10 equals to 10, or 100 equals to 10. Okay, so this is a higher range if you want to, and we can change it of course by using this. Now this has some electronics inside it. It needs some biasing, okay, to be able to operate. So this is just a voltage source connected into this to enable this to work, and this is just simple 12 to 14 volts that is connected to it. So you can put it in any value in this range, 10, 12 to 14, to make it able to work. So what will happen is now I will change the voltage, and for each voltage I will be measuring a voltage here, and that voltage will correspond into an electric field. And you can see in your table we have voltage that is varying, which is our voltage applied on the parallel plate capacitors. This is the voltage that we are measuring using our electric field meter. We call it probe voltage, which is this one, and then we will of course convert it into electric field. We said the relation is going to be 1 kilovolt equals to 10 volts, or 10 kilovolts equals to 10 volts, or 100 kilovolts equals to 10 volts, depending on which range of your electric field meter you are using. Okay, now what the first thing to do is now to make sure that your distance is set to whatever you are having there. So we say we want to have 10 centimeters, so I will just use 10 centimeters in here, and we measure it from inside to inside. So this is 10 centimeters. I have to make sure also it is 10 centimeters from the other side. It is not, so I have to make sure to make it 10. So this is also another 10 centimeters. Now change it here, so I have to make sure that have it 10 centimeters. They have to be 10 centimeters from both sides in order to be able to measure them. Okay, so this is 10 centimeters now, and then we will vary the voltage. Okay, 10, 20, 30 until we reach to 110. But before doing this, you cannot, although the voltage is 0, there is some reading here, and we need to compensate for this reading, which means we need to do some calibration, and this device allows us to do calibration by using this small knob. I can change this to make sure that for 0 voltage we will be having 0 electric field. So I'm just varying this, and I'm getting 0 volts equals to 0 electric field. So this is just for calibration. Okay, so now this is calibrated, 0 equals to 0, and I will start changing it. Of course, I can change this if I want to. I can use the 3 or the 10 or the 30 or the 1, whichever I want. This does not change the measurements that you are doing. It will give you a better resolution if you want to. So let's say if I am using the 3, it means I will be using the lower scale, and the maximum will be 3. So whatever is there, I will be dividing it by 10. So the 20 will be 2, the 10 will be 1, and the 30 will be 3. If I am using the 10, then I will be using the upper scale, and the maximum will be equal to 10. So this will be 10, this will be 8 and 6 and so on. If I am using the 1, then I will be using the upper scale and dividing everything by 100, because the maximum will be always 100. So you cannot, whenever you use 1, 10, 100, you will be using the upper scale, and whenever you use anything that contains a 3, so 0.3, 3 or 30, you will be using the lower scale, and the maximum will be equal to the value that is given there. So this is 3 now, it means maximum will be equal to 3. So this will be 2, this will be 1, and every division, of course, you can see how much it will be. You need to make sure that whenever you want to take a reading, you have to be perpendicular to the meter, and you have to see the needle that you have here, and below the needle there is a small mirror that they are matching, and then you will be able to take the reading. Okay, we will take the reading for you, so you don't need to worry, but you need to know how to take the measurements for every of those devices. So let's say this is my device now. I calibrated it into 0. Everything is 0. I'm using the 3 volt division. So maximum is 3. Now I will put a voltage of 10 volts. So this is my first reading was 0 equals to 0. Voltage equals 0 electric field. Now I will change this into, you can see the voltage. I will change this into 10 volts. So this is okay, 10 volts. So we're putting 10 volts. Now when we have a 10 volt, it's a little less than 10. Let me make sure it is equal to 10. Okay, so this is 10 volts. Now for 10 volts, I would like to see how much will be the electric field, and this is a voltage that represents an electric field. So the probe is saying now we are in 3. So this is 3, this is 2, and this is 1. So we can see that it is equal to something like 0.95 volts. Okay, so this is 3 is maximum. So this is 3, this is 2, and this is 1. So you can say that this is equal to around 0.9 volts. Then you can multiply this, of course. 95, you said 0.95. So you multiply this to get an electric field of something like 95 volts per meter. And now we will make this 20. So we will raise this to 20. And you can see that this is 20. And we see how much is the electric field here. And you can note that it is something like 1.8. Okay, 1.8 volts. So when you convert it, you will multiply by 100. So you will say 180 volts per meter, and then you will increase this into 30. Okay, so we are putting 30 here now. Okay, so this is 30, and for the 30 it is something like, this is 20, this is 30, this is 29, so this is 28. So you will say 2.8 2.8 volts, or equals to, you multiply it by 100, so 280 volts per meter. Now we are very close to the end of the range, so we need to change into the 10. So I will change the 10, and I will be putting now 40. So we are putting 40. Okay, so this is 40, and for the 40 now I am using the 10 scale. It means I am using the upper scale, and this will be the maximum, and this means this is going to be approximately 4. Okay, this is equal to 4 multiplied by 100, so 400 volts per meter. We will go for 50. So this is my 50. Okay, so this is my 50, and this is 4, this is 6, so this is 5.8. okay, 5.8. so you multiply it by 100 to get your electric field. And then this is my 60. Okay, so this is my 60. Raise it a little. Okay, so this is 60, and the voltage here is, this is 4, 5, and this is 6, so this is 5.8. So you multiply it by 100. Okay, and then we go to 60. We did 60, so we go to 70. Okay, so this is my 70. Okay, so this is 70, and this is 68. Okay, 68 or 6.8. Okay, 6.8, and then we go for 80. Okay, for 80, and this is 7.7. Okay, 7.7, and then we go for 90. So this is 90. Okay, 90, and this is okay, 8.8. Okay, now we are getting very close to the 1 kilovolt, so we need to watch. If we reach 1 kilovolt, then we have to go to the next range, otherwise our readings will be saturated, so we will not take a reading for that. So I will switch now, because I'm already very close to the 1, so I will switch this, and you cannot switch it into the next range, which means now every 10 will be equal to 1 kilovolt per meter, which means instead of multiplying by 100, we'll be multiplying by 1000 in this case. So you can see that the reading is now very low, very close to 1, but it is very low because it will be multiplied by 1000 instead of by 100. So I will go now for the 100, and I'm just reducing this scale now to 3. So you can see it is very close to 1. I'm using the lower scale now. You can see that it is 0.9, maybe 5 or 6, 0.956. You will multiply it by 1000. Don't forget, we were multiplying by 100 for the first part. Now we are multiplying by 1000 because we changed the range that we have here from the 1 equals to 10 into the 1 equals to 10 equals to 10. So 1 equals to 1 in this case. Then we go for the last reading, which is 110. So this is our 110, and for 110 we can see that this is something like 1.2, 1.1, and this will be my voltage that corresponds something like multiplied by 1000, so it will be 1100 volts per meter. So this is the last one, 1100, or this is about 1.1 volts, because it will be multiplied by 1000. Remember, we were multiplying by 100 for the first parts, and then we switch it into the 1000 because we changed the range here. Otherwise your data will be completely wrong for this case. So I'll make sure that this is equal to 0, and we should go back again to 0 equals to 0 where we started. Now in the second part, we will be varying the distance between the two plates, and for every distance we will be measuring the same thing, the voltage, and this will be corresponding of course to an electric field, and this will be done for a specific voltage of 100 that will be putting there. So what I will do is I will raise the voltage into 100. Okay, so this is 100. So this is 100, and I will keep this 100 as it is, and I will be just varying the distance between the two plates for different ones. Now we know that this was already set for 10, so instead of starting from 2 going to 10, I will start from the 10, because I already have for the 10 the reading. I will take the reading for the 10, and then I will start going back again into the lower ones. So for the 10, I can see I'm using the 3 scale here. It is 0.95, okay, and it will be multiplied by 1000. Okay, it will be multiplied by 1000 because we are using the second rate. Okay, this is very high, 100 volts. Now we will go for the next one, which is 8, and I expect that the voltage is the same, but the distance is decreasing, and because of this we expect the electric field to go higher. So I will not change the range, I'll keep it as it is, otherwise it will be a problem. It will be of course always much safer if I reduce the voltage into 0 and then change the distance, because if I touch those, they have already the voltage there, and it will create problems of course in this case. So I will change the distance now into 8 centimeters. So this is my 8 centimeter. I have to make sure that it is also 8 in the other side. So this is 8 in this side and 8 in this side. So I have to make sure they are 8 in both sides. Okay, so this is 8 and this is 8. So I will put the voltage now to 100. This is my 100 and the voltage is 8. So now I'm doing this one now, and you can see that the voltage here increased also beyond the 1. So we will be multiplying by 1000. Don't forget this. This is 1.1. Okay, so is it 1.1? 1.05. Okay, 1.05 multiplied by the 1000, and this will be the reading for your electric field and the voltage. And then I will change the distance into 6 centimeters. So I will change this into 6 centimeters. So this is 6 centimeters. I have to make sure that they are parallel, so I have to measure them from both sides. Okay. Okay, so this is 6 from here and 6 from here. So now we are okay, and now we can measure. The voltage is still there, the same thing, 100. I didn't change it, just fluctuates a little. Now for the 6, the reading here is, this is 1. I'm using still the 3 scale. So this is 1 and this is 2. This is 5. So this will be 4. So it is 1.4. So 1.4 we will multiply by 1000. So this will be 1400 in this case.
This was 8 centimeter?
Yes, this is 8. This is 6 centimeter. No?
This was 6 centimeter.
This is 6 centimeter. Yes, this is 6 centimeter.
Now we'll go for.
Now we go for the 4. So I will go for 4. So this is my 4. Let me measure from this side. So this is my 4. Okay. Okay, so this is 4 and this is 4, and for the 4 now you can see it is shooting, it is going very high. It is nearly 2. Okay, so this is 2, and don't forget you will multiply it by 1000 to get you this, so it will be something like 2000 now. Okay, you remember we were starting by 100 and then 200 and so on. Now we are already 2000. So this is very, very high electric field. Now I will go for the 2 centimeters. I have to be very careful, because if I touch them, both of them, as if I am short circuiting my voltage of 100 volts, so I have to make sure that I go slowly otherwise I may create problems on the other side. Let me, okay, so this is 2 centimeters from here. 2 centimeters. You have to be very slow, because if you touch them, you are short-circuiting the 2 voltage terminals that you have here. And of course, you can see now this is shooting more than 3, so it will be more than 3000, of course. And you can see it is 4 now. I'm using the upper scale. I'm using 10, so it will be 4, around 4. So it will be 4 times 1000, so it will be 4000 in this case. Okay, so this is for the 2, and this will be the end of the second part. Now we will do the third part. Okay, and in the third part, what we will be doing is we will be putting a material in between, and this is just simple wood. We can have different types of materials, and we can try all of them if you want to, but we will be using this. This is nearly 1 centimeter thickness, but because of the screws that we have there, it may not be exactly 1, but it will be very close to 1. So what we will do is we will put this inside, and then we will try to put them all the way together, just to minimize the distance, as if now there is no air inside. Of course, there is a small portion which contains an air, and because of the screws that we are using for those, they will be pushing the wood a little, so they will give you some errors, but still it will work. So we are putting now distance of 1 centimeter with a material of wood, and we would like to see what happens to the electric field as we change the voltage that is applied to it. Okay, so we will start from this. Voltage is set to 0. I will try to calibrate it to be 0 equals to 0. Okay, because I put a material there, may affect the readings. So this 0 equals to 0. Let me even use the 3. Okay, now I will start increasing. So for 0 equals to 0, and now I will put 5 volts. So I will increase this into 5. Okay, so this is 5 volts. Okay. Okay, so this is 5 volts, and now what I am reading is, remember I'm using the 3, so this is 3, this is 2, this is 1, so this is 0.5, and I'm using the second range, so I will be multiplying by 1000, so 0.5 multiplied by 1000, so we are talking about 500. And then we go for the next one, which is the 10. So we will be putting 10. Okay, so this is my 10, and again I'm using the lower scale, so this is the 3, and you can see that it is very close to 1, or it is 0.96 or 97 if you want to. So 0.96 or 0.97 multiplied by 1000, so this is something like 970 volts per meter in electric field. And then we will go for 15. So this is my 15. Okay, a little more. Okay, so this is my 15, and for the 15 this is 10, this is 15, this is 20, so this is 14, but because I am using the 3, it will be 1.4. So 1.4 multiplied by 1000 for your electric, this is 1.4 here, and for the electric field will be multiplied by 1000, so it will be 1400. And then you go for 20. So this is my 20. Okay, so this is my 20, and for the 20 I'm still using the 3. This is my 2, and this is 1.5, so this is about 1.8. okay, a little more than 1.8. Again, you will multiply by 1000. We didn't change anything in the range there. And then we will go for 25. Oh, we don't have 25, that's enough. So this will be the last part that we have for the voltage. I have to make sure now this is just 0 for safety, and then I will switch my electric field back to 0, and you can notice now the fan is off. It's not working. Fan is off because I switched the power that is supplying the voltage to operate. So this is not no more operational, and you can see that no voltage is coming and everything is off because the power is this is like the biasing voltage or the battery that you need to supply to the device to be able to operate. So we had 3 parts. In the first part we changed the voltage for a specific distance. For the second part we changed the distance for a specific voltage, but for all of them we had air inside. Now in the third part we put a wood in there, and then we were varying the voltage, and we would like to see that we will have the same type of trend like the first one, because what we did is we fixed the distance and then we varied the voltage, so that will be very similar to this in terms of relations, but instead of having wood air, we are using wood, of course, for the second part. So this will be the end of our experimentation for experiment number 1. If you have any questions, of course, you will discuss it with your instructor after you play the video. But remember, collect the data, fill in the tables, and then prepare your reports the way your instructor told you to prepare, and you will be submitting them using your Blackboard as usual. Thank you very much, and appreciate you listening to us.